Welcome to Study Loop.
Okay, so we have to prove two things. First, that if a function is strictly increasing, then it is one-to-one. So if f is strictly increasing, then when x is less than y, we need f as a function of x is less than f as a function of y, which is definition of strictly increasing. Now to prove one-to-one, we have to prove that when f as a function of x is equal to f as a function of y, this implies that x is equal to y. So first off, we will kind of do two things. First off, what we'll show is we'll show that when we'll show that x can not be greater than y, and we'll show that x cannot be less than y. So to show this, so when x is greater than y, we need, by definition of strictly increasing, f as a function of x is greater than f as a function of y, which implies that f as a function of x cannot be equal to f as a function of y. So then this case, so when x is greater than y, so x cannot be greater than y. That's what this is saying. Now, when x is less than y, once again, strictly increasing, we have f as a function of x is less than f as a function of y. So, which also implies yet again that f as a function of x is not equal to f as a function of y. So you have two different cases where f as a function of x is not equal to f as a function of y. So the last case that you must have, therefore x must be equal to y, because if x is greater than y, which is this case, well, you don't have equality, and when it's less than y, you don't have equality as well. So you are left with x is equal to y. So therefore, and f of x is 1 to 1. Now B, we give an example of an increasing function of r that is not 1 to 1. So a good example is f as a function of x is equal to ceiling of x. So this is an increasing function, which when you draw it, you have something like this. So this is 1, and then jump to 2. This is dot, and this is circle, 2, 1, 2, and it keeps going on like that, right? So it's an increasing function, but it's not a strictly increasing function. And so therefore it's not a one-to-one function, because f as a function of 0.5, which is ceiling of 0.5, is equal to 1, and f as a function of 0.66 is equal to ceiling of 0.6, which is also equal to 1.